I would like to invite our esteemed chairpersons, Mr. Shafat Alam and Mr. Farooq Saghir, to please come on the stage. Please have a round of applause for them. I would like to have a brief introduction of both our esteemed chairpersons. I will start from Mr. Shafat Alam. Mr. Shafat Alam did his MSc in Geophysics from Quaid-e-Azam University and thereafter joined PPL in 1990. Later, he worked for Lesmo Oil, that is ENI Pakistan, Petronas Karagali Pakistan, and Mari Petroleum Company Limited in different capacities. In 2013, he rejoined PPL and looked after overseas blocks. He has vast experience of over 32 years in analyzing onshore and offshore seismic and well datasets and has many hydrocarbon discoveries as feather in his cap. Presently, Mr. Shafat Alam is working as Senior Manager Exploration in ST and SS in PPL, providing prudent support to the assets in satisfying the work commitments. It's an honor to have you here, Mr. Shafat Sahab. I'll now go through the profile of Mr. Farooq Saghir. Mr. Farooq Saghir is a business and technical leader working as ED Exploration in OGDCL. He has extensive oil and gas upstream industry experience, recognized for demonstrating a natural aptitude for business solutions as well as for creating innovative exploration, development, and operations programs in the most complex and challenging geological and operational settings. Over the years, he has made significant contribution to several multi-billion-dollar upstream projects in North America, South America, Africa, Southeast Asia, Middle East, and Europe. He holds a proven and verifiable track record of contributing to company expansion and growth through quality delivery. Professional achievements include leading technology innovation, portfolio management, business strategies, new business development, acquisitions, divestments, front-end development, geosciences excellence, sourcing, stakeholder relationships, technical program implementation, contracting and procurement strategies, quality decision, risk management, and HSC for upstream business. Mr. Farooq has a master's degree in petroleum geoscience from Karachi University, Pakistan, and a master's degree in project management from Curtin University, Perth, Australia. It's indeed an honor to have you here, Mr. Farooq. So, before I hand over it to the esteemed chairpersons, again, we'll be having 3 presentations in this session. The time limit for the presentation is 20 minutes, and after the 15 minutes, you will be given a warning by the bell, which means that you have to conclude it within 5 minutes. So as there will be 3 to 4 questions for each group after that, but you have to ensure that you have to complete it in time. So I'll be handing over it to our esteemed chairpersons. Sir, over to you.
Thank you for the introduction. We will start the session with the first paper from Asad Taimur. Asad Taimur is currently associated with Geoscience Services team at LMKR as geoscientist. He has a master's degree in geophysics from National Center of Excellence in Geology, Peshawar. His area of expertise in seismic interpretation, QI, and open hole log analysis. He is also involved in day-to-day integration geoscience studies related to his tasks. Please welcome Asad Taimur for the paper. Okay, thank you.
Thank you very much for the introduction. Ladies, gentlemen, good morning. Building upon the phenomenal technical sessions that we've had so far, I'll be talking about carbon storage, one of the hottest topics in our industry today. Now, we've tailored this study to create synergy between spatially driven surface screening and machine learning-based subsurface characterization for carbon containment. First and foremost, I'll set the stage with the rationale. I'll touch upon 3 success stories from around the globe. Then we'll track back to Pakistan, where I'll discuss a CCS-centric geological context. In continuum, I'll steer you through the methodology for spatial screening and reservoir characterization. Then I'll discuss the results and conclude the presentation with some recommendations for a way forward. Now, climate change is a reality, and unfortunately, Pakistan is amongst the top 10 countries which is affected by extreme climatic events. And this is kind of ironic because we contribute to less than 1% of global carbon emissions. However, the UNFCCC, in collaboration with European Union and other stakeholders, has created a carbon trading system under the ambit of climate markets, which is on the verge of implementation globally. So how it works is that we store some carbon and we gain some credits for that, and we can trade them with other countries which are having a hard time offsetting their carbon footprint. Another obvious advantage is that wherever we get this carbon from, particularly the industrial areas, we're going to be improving the local ecosystem and the air quality, which is a big problem here in Pakistan. Since we've not had this implemented in Pakistan yet, so surface screening and subsurface characterization integrated together will be a step in the right direction for the subsequent policy synthesis and implementation. Globally, carbon capture is a mature technology. It's controlled, and it's been going on for a while now. The first ever commercial project was the Sleipner CCS in the North Sea. It's been running since 1996 and has a storage capacity of 0.9 megatons of carbon per year. The Petronova CCS is in the US. It's relatively recent. It got implemented in 2016 with a size of 1.4 megatons of carbon. The Quest CCS in Canada, it has a size of up to 1.2 megatons of carbon storage per year, but this is onshore, and the Petronova is also onshore. Now, you might notice here that all of these projects have different sources of carbon, which highlights the versatility of this technology. Let's re-navigate to Pakistan. So in line with global best practices, whenever we're planning to do a CCS project, we have some key, let's say, a criteria to do that. So we look for deep-seated reservoirs. I wouldn't want the carbon to be anywhere near my shallow subsurface aquifers. We look for structural geometries which are conducive to carbon containment. Then we look for mature oil patches. The first advantage is that usually the mature fields have wells which are depleting or near depletion or are depleted. And the second advantage is that we are quite familiar with the depositional extent of our reservoir, its internal architecture, and the structuration in that area, because we have a wealth of studies there. This also kills the cost for further acquisitions to the operator. Now, we have a 2-step methodology. And, one more thing. So yeah, based on these criteria, we chose the Potwar Plateau, and the oil fields of the southern Potwar deformed zone seem like a good place to start investigating. Now, we have a 2-step methodology. In the first step, we identified key carbon-centric indices and mapped them on the Potwar Plateau. After we map them, we stitch them together through a weighted overlay map before our final site suitability analysis as the final step. In the second phase, we performed the reservoir characterization. We resolved our frequencies, our seismic to its frequencies through continuous Taylor transform, which is compute efficient and provides better results than the traditional Fourier transform. Now that we have our seismic, we need, since we're dealing with a carbonate reservoir here, so we estimate the dolomitic volume and the porosities. Now that we have our seismic and well properties, we link them together through neural networks, which has the advantage of predicting our well properties on the seismic. As a final step, once we have our zones of interest, we perform a volumetric estimation, which is theoretical in nature because this is kind of the first study here, so we just to have an idea of how much carbon can be contained. We have some promising results here. The albedo index, which is one of the spatial indices, is basically the measure of how much solar radiation can be absorbed by the surface. The suitable range for this is 0 to 1, and okay, if you can see the red rectangle, we have screened that area in that red triangle. Then we would want to have lower initial surface temperatures. We have the surface temperature map. The slope and elevation link directly to the soil stability, which is important to keep the carbon in the subsurface in case it leaks. So we have the slope map is mostly green, which is good news because this represents a gentle basinal slope. The elevation map shows, we've highlighted it in red again. I'm sorry, I don't have the pointer here, but so we have less variation in the elevation, and we have a gentle basinal slope. So this is very conducive to our intended use. For long-term monitoring, the sulfur dioxide content is also a key indicator. Now, we would want to have minimal initial sulfur dioxide content on the surface, because in case the carbon leaks and reaches the surface, these two mixed together can cause a catastrophe in terms of poisoning the local ecosystem. Now we stitch all our maps into this some overlay map, and we've segregated this into good carbon storage site, average site, and poor site. So our study area, which is in the vicinity of the southern Potomac deformed zone oil patch, is in the good carbon storage site. So this concludes that the oil fields within the SPDZ, the southern Potomac deformed zone, are conducive to carbon storage. Now let's have a look at the reservoir characterization part. So first of all, on the right-hand side, we resolved our seismic into its real, imaginary, and magnitude frequencies through the continuous wavelet transform. We estimated our well properties, so we can see that we have a dolomitic zone in the top and the bottom part of the Eocene carbonate, and we linked these two together through the neural networks. Once linked, we matched the dolomitic volume on the right hand. On the left hand side, we have the dolomitic volume, which shows good correlation with the frequencies of our seismic, and the neural network has beautifully predicted our zones of interest in red in the maps below. So the left hand map represents the top part of our carbonate, and the right map represents the bottom part of our carbonate. On the on the right hand side, we have our porosity, which has a decent match with our seismically driven frequencies, and again we can see the effectivity of using machine learning, that it has populated our seismic grid with higher porosity areas. Now that we have our zones of interest, So now that we have our zones of interest, we use our depth map to take the area, and we have an area of around 30 square kilometers, and we modify the traditional volumetrics equation to suit our needs, because we are trying to inject carbon back into the reservoir, so we don't want the movable part, rather we want the connate water. So our estimation results in a storage capacity of 4.31 megatons of carbon. Now, these are very preliminary results, and the more data we feed to our neural networks, our results will improve. So, lastly, I would like to conclude this presentation with some recommendations. Now we've seen the effectivity of remote sensing methods. They can play a good role in carbon screening phase. It is recommended that index mapping be done periodically so that we can assess the surface variations over a period of time. Deep reservoirs, they are good for carbon storage because they offset the chance of carbon leakage and contamination with the surface aquifers. Carbonates do have the possibility of being good reservoirs, because particularly when they're dolomitized, because intraformational porosity contrast can act as a flow barrier for carbon. As a way forward, oil and gas fields and industrial complexes have to cooperate, because there's one segment of capture and then there's the other segment of storage. So we have the storage facilities well set in, but the capture part is currently missing on the landscape. So we would appreciate if there could be a good collaboration between the industrial sites and the oil and gas operators. Policy formulation in this regard is critical at this stage, particularly when there's a global push towards climate change and offsetting carbon. So we have to link our the carbon that we offset or contain to the carbon credit, so that we can gain some meaningful revenue for our government. Last but not least, I would like to acknowledge the Directorate General of Petroleum Concessions for the dataset used in the study. We are grateful to our management, and we also acknowledge our technology partners, Esri, for the software used in the study. And this concludes the presentation. Thank you so much.
Thank you, Asad Taimur, for presenting the CCS in a case where you have quantified the storage capacity in dolomites. And also identifying the requirement of the policy which is needed for the CCS in Pakistan and carbon credit as well. Let me ask a first question, and then we'll open a floor for the audience. My question will be that the biggest challenge for CCS around the world is the containment. So did some work on the seal capacity or capillary entry pressures for the seals as well? That might be one of the challenge in the CC at the moment, yeah.
Well, we have the Murray shales on top of our Eocene carbonate, so they are good reservoirs. We haven't particularly worked in this direction because we've had plenty of research published already. So we wanted to drive you through the reservoir characterization strategy. So we will look into it as well.
Thank you. So now I will open the floor for the question answers, and please start with your introduction and your question, please.
This is Dr. Shabir Ahmed from OGDCL. Mr. Taimur, you have presented on one of the biggest mission of the world, that is decarbonization and reduction of the carbon dioxide. Ultimately, it is threatening rising temperature and this. You have shown feasibility in northern Pakistan. There is geological feasibility. So should we think about the source of CO2? Likewise, I am thinking gas fields which are nearby paleo highs are emitting or contributing more percentage of CO2. So we should have feasibility nearby these sources.
Yes. Yeah, this is about the capture market. So basically, we need to have enough carbon to make it commercially feasible. So if those fields are producing enough carbon and it's high they're producing, then definitely I think this is worthwhile. And if we include our industrial complexes as well, then I believe this is a very, very good avenue to work.
Adding to Dr. Saab, basically this is a pilot study, you can say, and we have to see both the sides. Where is the source of the carbon and where we can utilize it as a reservoir to dump that carbon in a particular reservoir. So initially we think that a depleting reservoir would be best where we can dump that one. And that's why basically in order to keep the different views in our mind, we fix this particular story.
Yes, yes, it's a part of sustainable development goals towards the renewable and clean energies, and this is one of the good idea. And in next presentation, we will also present on such aspects. Thank you.
Thank you. Thank you very much.
Thank you. Next question, please.
Okay, I am Farasat Shah, Director Exploration at MOL, Pakistan. My question, maybe a subsequent question, will be related to what Dr. Saab has just asked the first question. I just want a little explanation of when you initially mentioned some factors that will determine the suitability of any area for this kind of work. You mentioned something related to the solar energy. That was, is it something?
Solar radiation.
So is it similar like solar irradiance index or solar absorption?
Yeah, solar,
It's
exactly.
the same thing.
Yeah,
So in that case, the most suitable area where the solar irradiance index in Pakistan is available is Balochistan.
Yes.
It is like 6 and above.
Agreed.
So,
Agreed.
and the gas fields, many of them are also over there.
Yes.
So, you know the question, you can answer.
Yeah. Basically, sir, we were working on in an area where we have developed already seismic and subsurface information available at a maximum level. So keeping that particular in mind, because Balochistan is under development and we have to study the reservoir portion, seal portion in depth, and maximum data should be available to analyze those things. So basically that's why. And the second thing is the data we utilize here that was only available for this particular site. By keeping in view that this is a depleted formation and near to deplete field, that's why, and the data maximum data set was available, and our technology can work by utilizing two-layer methodology. That's we focus here. And your approach is quite okay. That area would be the future possibility where we could extend our study to those areas of Balochistan.
Okay, thank you.
Thank you.
Thank you very much. We still have 2 more minutes and we can take one more question if there is any. Thank you.
Assalamu alaikum. My name is Farooq Shehzad from GHPL. This is a really wonderful article and study and good presentation. Just my question regarding the commercial feasibility of this project in future. So is there any sort of references available to show that this would be a commercially feasible with respect to Pakistan specifically? Thank you.
So basically, we cannot ascertain that as because currently we don't have a capture market, because there are 2 parts to this. One, we have to capture it. Second, we have to inject it. So we have shown you a workflow for the reservoir characterization flow, that it is possible to do it in Pakistan and we can gain some meaningful revenue. But again, we have to look into the capture market, and if there is no capture market, then we have to create it for this. So we have to look into the economics for that, and so it needs some working to do.
And lastly, we have recommendation that there should be a policy making body that should focus on the rest of the part. Basically, we are geoscientists and we have done our part. And that should be the other party that have to develop this policy making suggestions and etc. And that would. Thank you very much. Thank you very much, sir. Thank you.
Thank you. This will conclude their paper, and we will announce the next paper.
Next paper is by Mr. Waqas Habib, and the co-author is Dr. Adil Nadir as well, who will be coming on the stage to present it. But I have the introduction of Mr. Waqas Habib, the main author here. Mr. Waqas Habib is MPhil in Geophysics from Qaeda University, Islamabad. He has diverse experience of more than 17 years in oil and gas industry, from seismic data management to seismic data acquisition and seismic data quality control. He is also experienced in on-site processing of 2D and 3D seismic data. He is currently working in Geophysical Division of Exploration Department in OGDCL as Senior Geophysicist. He is also PhD scholar, and his PhD research is on carbon capture and storage in geological sites. He has presented his work in many national and international conferences and workshops. Ladies and gentlemen, please welcome both of the gentlemen. Thank you.
Thank you, Session Chair, for the nice introduction. Today I am going to present one of the global mission of the world, which is the reduction of carbon dioxide. As the increasing level of carbon dioxide is the life-threatening for both onshore and onshore. So, these are the contents of our presentation. We have divided our presentation into two parts. In the first part, we will discuss the greenhouse effects and greenhouse gases in relation with the UNO Sustainable Development Goals, significance of Paris Agreement, net zero carbon emissions, and role of geoscientists and how they can play their role in energy transition. And the second part, we will discuss the geological model and carbon capture and sequestration. So greenhouse gases are basically referred to those gases that results in trapping of the heat into the atmosphere, which ultimately results in increasing of temperature of the Earth and as a globe. There are different greenhouse gases, but major portion is by carbon dioxide, which is taking 76% of the greenhouse gases, followed by methane and nitrogen oxide. This is a temperature anomaly map. Here we can see that as far by 2020, we have already 1 degree centigrade rise in temperature as compared to the pre-industrial level. This rise in temperature will result into the melting ice caps in the Antarctic portion, and almost 149 gigaton of ice sheets has been melting every year, which ultimately results in rising of the sea levels, and it's a major threat for life. This is how the greenhouse gases affects, and this is greenhouse gases phenomenon. The sunlight that coming from to the Earth, most of the light reflected back into the space. But if the content of carbon dioxide and other natural gases are high there, these heat are being trapped into the atmosphere, and it will result in the increase in the temperature. Therefore, the United Nations has developed his own 17 goals, and the goal of the United Nations are many of them are related to energy transition, energy and climate issues, and the goal is also to mitigate this climate crisis by 2030 and getting the peak of these emissions as soon as possible. This is the Paris Agreement, which was concluded in 2015. And this is a binding and legal obligation on many countries. It's almost 196 countries who are the signatory of the Paris Agreement. And Pakistan is one of the signatory country of the Paris Agreement. So it's the legal obligation, you can say that. And it says that every 5 years, every country must have to communicate their nationally determined contributions, and they must show their achievement, their progress in relation to mitigation of the climate change. And for first NDC was in 2020, and the next will come in 2025. And finally, it goes to up to 2050 with the goal to achieve net zero carbon emissions. And here we can see that between 2020 and 2023, there was a global stocktake, and the global stocktake are the basically progress or the assessment of every nation. So it is necessary to have the ambitious targets and to have more realistic targets in NDCs. And here in the right side of the picture, it shows that if the current policies are not favorable in the sense, and there is a report that if we keep on using fossil fuels and same emissions are going on, then the temperature of the earth will rise by 4 degrees centigrade by 2100. And some reports also suggest that even it can happen earlier than that. So the current policies, if we go on with the current policies, then the temperature will rise by 3.5 degrees centigrade. Governments all over the world are trying to mitigate this effect. But that is also not favorable, and if these effects, if these efforts are going, then even we can only cut 3.2 degrees centigrade. Where the Paris Agreement, Article 2 says that we have to achieve the 2 degrees centigrade and most preferably 1.5 degrees centigrade. So there is a progress gap. It means much have to be needed to emissions. This is how to align fuel production and consumption. There was a debate after Paris Agreement. Most of the nation debates that how can we quickly switch from fossil fuels to new renewable energy resources. So there was the Talanoa dialogue. The purpose of that dialogue was to facilitate the governments, the stakeholders and policy makers to they can switch swift transition of the energy. These are the NDCs, and these are NDCs of the Pakistan. And here we can see that the Pakistan intends to reduce its emission by 50% by 2030. And it can only be done, and 15% of the reduction will be done by the country's own resources, whereas the rest of the 35% emissions will be reduced, which will be subject to the foreign support or foreign aid. But the 15% reduction is still in our end, So, and how can we achieve that? Therefore, it can be only achieved to switch from fossil fuel energy to renewable energy resources. So Pakistan intends to switch from by 2030 to 60% renewable energy sources and 30% electrical vehicle. So these are global emissions of carbon dioxide. And here's a map of the world which shows that the major contributor in global emission of carbon dioxide is China, followed by United States, then India and Russia. These are the top 10 carbon dioxide emitters in the world, with China on the rank number 1 and South Korea on the 2, South Korea on the 10. And Pakistan ranks at 28 in carbon dioxide emissions. Here we can say that the top 4-5 major countries producing carbon dioxide, they produce more than 60% carbon dioxide of the world. And emissions of Pakistan are not much, but still we need to follow the NDCs that we have committed from Paris Agreement. And right side figure shows that the major emitters are the coal, and coal is contributing 87% of carbon dioxide, followed by oil and gas. These are the territorial emissions of Pakistan. which shows that majority of the majority of the carbon dioxide are producing from the oil fields, and then gas and coal are also contributing. This is the very interesting slide. It shows the carbon dioxide emissions that can be used commercially, if they can be used commercially. By 2011, 50 million ton of carbon dioxide could be used as the in different industries. But latest report says that the consumption is increased by 280 million ton per annum. And
but it is less than 1% from the total carbon dioxide emission. Less than 1%.
Yes, but we have also not much sequestration capacity as well. The world is only sequestrated carbon dioxide about 40 million per ton annually. So 280 million per ton carbon dioxide, if you utilize, that is a thing to mention. There was an article published in American Journal which shows that the geoscientists will be backbone of the energy transition, and they mentioned that the skill required for the oil industry and skill required for the geoscientists can be used in diverse industries and diverse categories. Here is the poster which was published in Geological Society of London, and they have linked the role of geophysics with the Sustainable Development Goals which was set by UNO. And here carbon capture and storage. Here is carbon capture and storage is one of them, and other energy storage, gas, hydrogen, because it is known that geoscience is only for oil and gas industry, but this poster shows that there are diversity in geoscience, and this diversity we need it because the fossil fuels are going to deplete, and the effects of the fossil fuels on the climate has to be reduced. This is the role of geoscientists, and it shows from the left that the petroleum system and right on the pressure system, it shows that no other extra skills or expertise are needed for geoscientists to work in CCS industry. For example, in petroleum system, we have first to define or find out the sedimentary basins. Then we will have petroleum system, then petroleum play, prospect, and then we drill oil or gas well for that is commercial. But in pressure system, this is an analogy. There is a similarity between these two systems. We have to first find sedimentary basin, then there was petroleum system, but here is a pressure system. Then we will have a container play and prospect, and again the site for the safe storage of the carbon.
प्रैक्टिकली असल में जब आप कार्बन स्टोरेज की तरफ जाते हैं तो उसमें असल में आपको प्रेशर के साथ गैस को इंजेक्ट करना है किसी पोरस रॉक पे, तो दैट्स व्हाई दे कॉल इट एज अ जियोलॉजिस्ट और जियोफिजिस्ट एज अ प्रेशर इंजीनियर, और द सिस्टम डिफाइंड बाय देम दे कॉल इट एज अ प्रेशर सिस्टम, नथिंग एल्स. दोनों चीज़ें तकरीबन ऑलमोस्ट सेम है.
Now this is the geological part of the carbon sequestration, and Mr. Adil will present.
अच्छा जी, आप यहाँ पे अगर ये नक्शा देखें तो इसमें एक तरफ जो है ऊपर चाइना है, एक तरफ इंडिया है और एक तरफ ईरान है. अनफॉर्चुनेटली मैं यहाँ पे एक वर्ड इस्तेमाल कर रहा हूँ डेपो सेंटर था कि ये जियोलॉजिकल टर्म है, लेकिन पाकिस्तान जो है इन तमाम की पोल्यूशन के लिए डेपो सेंटर है. कैसे? आप ये देखें, ये जो आपका अरेबियन सी है ना, ये वेस्टर्न घाट्स के अलॉन्ग जो है ये नीचे तक जा रहा है, और जब हवा आपकी उठती है वो उसके साथ टकराती है और उसके बाद ये वेस्ट टुवर्ड पाकिस्तान ट्रैवल करेगी. दूसरी तरफ बांग्लादेश है, बांग्लादेश में चूँकि सारा प्लेनर एरिया है और हवा को मूव करने के लिए उसके लिए लाजमी है कि उसको कहीं ना कहीं एक, असल में जो प्रिंसिपल है ना आपका मूनसून्स का, वो स्लोप के ऊपर डिपेंडेंट है, रीजनल स्लोप के ऊपर, जो आपकी सी लेवल से टुवर्ड आपके हिली टेरेन की तरफ मूव करता है, और वही बैरियर है. तो वो बैरियर कुदरत की तरफ से कुछ ऐसा सेट हुआ है कि जो आपका बे ऑफ बंगाल से हवा उठेगी, वो ऊपर हिमालय को टकराएगी और फिर टूवर्ड वेस्ट जो है वो ट्रैवल करेगी। लिहाजा वो तमाम कार्बन डाइऑक्साइड जो कि इंडिया एक्यूमुलेट करेगा, उसका सारी की सारी वो एक्यूमुलेट आपके पाकिस्तान में होंगी। इसी तरह ईरान जो है वो नंबर 8 पे है। ईरान जो कुछ प्रोड्यूस करेगा, जो कुछ वहाँ से आएगा, वो भी जो है, चूँकि हमारे ये जो रेंजेस हैं, वेस्टर्न रेंजेस जो हैं, ये बहुत ज़्यादा हाइट नहीं है और ये जो मैकेनिज़्म है उसके लिए हाइट और एलिवेशन का होना ज़रूरी होता है, तो वहाँ से भी कुछ पोर्शन जो है वो हमारी तरफ ही आएगा। ठीक है जी। और चाइना जो है, चाइना के अलॉन्ग चूँकि बैरियर है, लेकिन चाइना से जो कुछ भी आ रहा है वो हमारे हिमालयास को इफ़ेक्ट कर रहा है। तो उसमें प्रैक्टिकली मैं ये कहूँगा कि मौसमियाती तब्दीलियों में पाकिस्तान का अगरचे हिस्सा 1% से भी कम है, लेकिन ये सरहद पार आलूदगी से शदीद मुतासर है। अच्छा जी, ये मैंने जो है ना कैलाश माउंटेन लगाया है।
डॉक्टर अदील एंड वकास, वी हैव 5 more minutes प्लीज।
ओके जी, ये कैलाश माउंटेन का मैंने लगाया है। कैलाश माउंटेन की एक जियोग्राफिकल पोजीशन अपनी तरफ है, जियोलॉजिकल अपनी तरफ है, मजहबी तौर पर इसकी अपनी, क्योंकि हिंदुओं का और बुद्धिज़्म का सबसे मुकद्दस तीन मकाम है। तो यहाँ पे जो कैलाश माउंटेन है, ये बेसिकली यहाँ पे 1 डिग्री आपकी टेम्परेचर एनॉमली जो है वो रिकॉर्ड की जा रही है। जब टेम्परेचर एनॉमली की हम बात करते हैं तो आपका एक एवरेज टेम्परेचर है और एक जो टेम्परेचर रेज हुआ है उसके डिफरेंस की बात कर रहा हूँ मैं। ठीक है जी। उसका इम्पैक्ट क्या है? ये लेक मानसरोवर है, ये लेक मानसरोवर को फेड करता है आपका कैलाश माउंटेन। अगर आप पिछली स्लाइड पे देखें तो आप ये देखेंगे 2020 में उसके ऊपर बर्फ़ ही नहीं है, 2003 में बर्फ़ मौजूद है। ये मानसरोवर आपका रिवर ब्रह्मपुत्र, रिवर इंडस, रिवर आपका सतलज और फिर कराली, इन चारों का सोर्स है। अगर आप, और फिर इसकी जो लेवल ऑफ, जो वाटर लेवल है वो डिक्रीज़ कर रहा है। इसका जो वाटर लेवल डिक्रीज़ करने का मतलब ये है कि जो आपके जो 2 इंपॉर्टेंट दरिया हैं, एक आपका रिवर इंडस जो पाकिस्तान को फेड कर रहा है, दूसरा आपका जो बांग्लादेश और इंडिया को फेड कर रहा है ब्रह्मपुत्र, वो डेफिनेटली आने वाले वक्तों में वहाँ पे पानी मौजूद नहीं होगा। अच्छा, ये क्लाइमेट चेंज जो है, ये इसका क्लाइमेट जो है ना एक इंडेक्स है जो कि रिस्क इंडेक्स है। इस रिस्क इंडेक्स में इस दफ़ा हम नंबर 8 पर हैं, लेकिन अगर हम डाटा को गौर से देखें तो 2018 में हम 5 पे थे। उसकी रीजनिंग ही यही। अच्छा, इंडिया एक ऐसा मुल्क है कि जो जिसकी सराउंडिंग में जितने मुल्क हैं वो सारे मुतासर हैं। उसकी वजह है असल में ये जो आपका ये जो ग्लोबल इसका जो इकनॉमिकल इम्पैक्ट है वो डिपेंडेंट है आपकी वेट पे ऊपर। पाकिस्तान की अनफॉर्चुनेटली जो हमारी जोग्राफिकल वेट है वो बहुत कम है। आप सुबह लाहौर के लिए बैठते हैं, पेशावर के लिए, शाम को आप पेशावर चले जाते हैं। इसलिए जो कार्बन डाइऑक्साइड जब वह जो आ रही होगी इससे जब वो कॉन्सेंट्रेट करेगी तो वो उसकी कॉन्सेंट्रेशन आपके इसी एरिया में होगी जहाँ से आपके हिली टेरेन शुरू होते हैं और वो लाहौर तक चली जाएगी। सेम विद द बांग्लादेश। चूँकि आपका जो इंडिया है उसके सेंटर में पहाड़ हैं और उसके सराउंडिंग में वेट अच्छी खासी है, तो इसलिए उसके अंदर वो जो कार्बन डाइऑक्साइड का इम्पैक्ट है उसको मिटिगेट होने के लिए काफ़ी टाइम भी चाहिए। दूसरा, एक एरिया में अगर उसका इकनॉमिकल रोल अगर मुतासर है तो दूसरे एरिया के अंदर उसका इकनॉमिकल रोल उसने उस हद तक मुतासर नहीं होगा। तो ये हमें एक्चुअली हमारी जोग्राफिकल जो वेट है वो मारती है इस हवाले से। अच्छा जी, ये मैंने बड़ा सिंपल सी एक डायग्राम हम लोगों ने बनाने की शो की। ये सारे सबको पता है, हम सारे मतलब पेट्रोलियम के साथ एसोसिएटेड हैं। पेट्रोलियम में सोर्स, रेजरवायर, सील है। आप सोर्स को काट दें क्योंकि कार्बन डाइऑक्साइड को का जो सोर्स है वो मैकेनिकल है और केमिकल है, तो बाकी रेजरवायर और सील की डेफिनेशन एब्सोल्युटली वही होगी जो पेट्रोलियम जियोलॉजी में हम देखते हैं, वही काम होगा, वही सब कुछ होगा। ठीक है जी। इसके अंदर जो है सिर्फ ये सोर्स डिफरेंट होगा। सोर्स के लिए आपको कोई ना कोई मैकेनिकल मेथड जो है वो अडॉप्ट करना पड़ेगा। जो यूएनओ की इन्होंने ये डायग्राम शो की थी उसमें भी यही है कि आपके मुख्तलिफ टाउन्स के अंदर आप कैप्चर करेंगे और उसको कहीं डीप बरियल आप जो है उसको लेके चले जाएंगे। अच्छा, ये कोई डायग्राम ऐसी नहीं है कि जिसको एक्सप्लेन करने की ज़रूरत है। प्रैक्टिकली कार्बन डाइऑक्साइड जो है वो नेचुरल अकरिंग गैस है आपकी सब सरफेस में। कार्बन डाइऑक्साइड जो है ये एक ऐसी गैस है कि जब ये ज़मीन के अंदर होती है तो ये वहाँ पे मिनरलाइजेशन भी करती है, मिनरल्स बनाती भी है, मिनरल्स में तब्दील भी हो जाती है, और ये सिर्फ उस वक्त ये गैसियस फॉर्म में होती है जिस वक्त ये आपके किसी लिक्विड फेस के साथ या गैसियस फेस के साथ इंटैक्ट हो। तो आपके वो तमाम चीज़ें जिसमें एंटीक्लाइन शामिल है, आपका जहाँ पे आपकी जो है वो रीफ्स हैं, फ्रैक्चर्ड लाइमस्टोन है, इवन आपका बेसाल्ट अगर वो फ्रैक्चर्ड है, तो हर वो चीज़ जो कि वो मौजूद है उसमें कार्बन डाइऑक्साइड को आप जो है वो दफन कर सकते हैं। और उसके बाद जो कार्बन डाइऑक्साइड है वो 2 साल या 3 साल बाद में से अक्सर जगहों के ऊपर वो किसी और मिनरलाइजेशन के अंदर जो है वो नेचुरली जो है वो कहीं और चली जाती है। ठीक है जी, ये बेसिकली मुख्तलिफ हमने उसके ये मैकेनिज्म एक्सप्लेन करने की बताया है। आप देखिए जी, सीलिंग इन्होंने फ़ारूक साहब ने सवाल पूछा था, सीलिंग बेसिकली आपका ट्रैपिंग मैकेनिज्म को डिफाइन करता है। सीलिंग मैकेनिज्म उसी तरह ही है जैसे आप पेट्रोलियम जियोलॉजी में देखते हैं। स्टोरेज मैकेनिज्म भी उसी तरह ही है। आपको पोरस रॉक चाहिए, फ्रैक्चर रॉक्स चाहिए। ट्रैपिंग मैकेनिज्म की भी आपकी 2 तरह की ट्रैप्स हैं, स्ट्रक्चरल है, स्ट्रेटिग्राफिक है। हाँ, एक चीज़ इसमें एडिशनल है कि अगर आपके पास फॉर्मेशन वाटर के अंदर जो है सैलिनिटी है तो कार्बन डाइऑक्साइड उसके अंदर एब्जॉर्ब भी होगी और मिनरलाइजेशन भी करेगी। ठीक है जी, और किस तरह के मिनरल बनाती है ये वाल्सोनाइट, डाइऑक्साइड, मैग्नीसाइट, फायरलाइट, सेड्राइट, इस तरह की एक लंबी लिस्ट है। बल्कि अभी दुनिया में एक नया मेथड आया, कार्बस मेथड। उसमें वो सिंपल जो है कंपनी से पूछते हैं अगर आप गैस ज़्यादा एमिट कर रहे हैं, वो ड्रिल करते हैं और उसके अंदर जो है वो कार्बन डाइऑक्साइड को बरी कर देते हैं। 2 साल के बाद जो है वो कार्बन डाइऑक्साइड जो है उसके अंदर मुख्तलिफ मिनरल्स के अंदर जो है वो तब्दील हो चुकी होती है।
Excuse me, gentlemen, I can understand your excitement and the interest, but you have 1 more minute, please.
ओके जी, ये सेल्फ एक्सप्लेनेटरी है जी। इसके अंदर जो मुख्तलिफ जो है इनर्ट गैसेस डाटा जो है वो यहाँ पे लगा हुआ है। ये वो फील्ड्स हैं जहाँ से जो है ना हमने ये भी जो है कार्बन डाइऑक्साइड प्रोड्यूस हो रही है। अच्छा, इसके बारे में मैं सिर्फ ये कहूँगा कि 2 बेहतर ऑप्शंस हैं हमारे पास। अब रिस्पेक्टिव ऑफ दिस डायग्राम कि अगर आपकी किसी फील्ड के अंदर कार्बन डाइऑक्साइड ज़्यादा है तो आप उसी फील्ड के अंदर किसी और फार्मेशन में आप उसको बरी कर सकते हैं, बशर्ते कि उसके अंदर पोरासिटी मौजूद हो, फ्रैक्चर्ड लाइमस्टोन हो, पोरस रॉक हो, इवन अगर आपके पास जो है वो क्या कहते हैं फ्रैक्चर्ड बेसाल्ट है, वहाँ पे भी उसको दफन कर सकते हैं। ठीक है जी, ये एक एग्जांपल है, ये सिर्फ एक बुकिश एग्जांपल है। इसका मकसद ये नहीं है कि मैं जिंदा बीर के लिए 100% प्रपोज कर रहा हूँ, लेकिन बेसिकली बात ये कहने का मकसद ये है कि आप अपनी किसी नियर बाई फील्ड के अंदर भी कार्बन डाइऑक्साइड को आप उसको जो है ना बरी कर सकते हैं। आप एक फील्ड से कलेक्ट करते हैं, दूसरी फील्ड से कलेक्ट करते हैं, उसके बाद आपके नियर बाई फील्ड में या जो डिप्लीटेड फील्ड है उसके अंदर आप उसको बरी कर सकते हैं। ठीक है जी, कंक्लूजन्स हैं। कंक्लूजन में सिंपल बात यह है कि कोल जो है वो मेजर सोर्स ऑफ कार्बन डाइऑक्साइड है। प्रैक्टिकली कोल एक चीपर फॉर्म ऑफ एनर्जी है। कोल में 2 चीज़ें हैं, एक CH4 है और एक उसका जो है उसके अंदर कार्बन होता है। दोनों जलते हैं। दोनों जलने के बाद उसकी जो कार्बन डाइऑक्साइड की रेशो जो प्रोड्यूस हो रही होती है वो आपके हाइड्रोकार्बन से ज़्यादा हो रही होती है। ठीक है जी, उसके बाद ये है कि हमें जॉइंटली जो है ना ये कोशिश करनी चाहिए, जो हमारे हमसाए मुल्क है, कि उनको हम बता सकें कि आपकी वजह से हम लोग कहाँ जा रहे हैं। और इसके लिए हमें जो है ना शायद एक नेशनल पॉलिसी की ज़रूरत है, क्योंकि जिस तरीके से ये टेम्परेचर रेस कर रहा है, शायद अगर आप उस ग्राफ को प्रोजेक्ट करेंगे तो 10-15 साल के बाद आपको पानी नज़र नहीं आएगा दरियाओं में। ठीक है जी, डिप्लीटेड ऑयल गैस फील्ड्स जो हैं तमाम की तमाम जो है कार्बन सीक्वेंस्ट्रेशन के लिए इस्तेमाल की जा सकती हैं। और एंड पे यही है कि CBM इज़ द बेस्ट मैथड, जो मैं यहाँ पे लिख नहीं सका, CBM इज़ द बेस्ट मैथड रादर देन टू माइन द कोल, क्योंकि CBM में आपका कोल नहीं जलता। आप वहाँ से चूँकि CH4 ले लेते हैं, कार्बन डाइऑक्साइड जो प्रोड्यूस हो रहा होगा उसकी रेशो ऑटोमेटिकली कट डाउन हो जाएगी। कि जी ये हमारी रिकमेंडेशंस हैं। रिकमेंडेशंस में जो 2-3 चीज़ें इंपॉर्टेंट हैं, उनमें एक तो यही है कि हमें अपने दरख्त जो हैं उनको लगाना चाहिए। दूसरा है हमें अपनी गाड़ियों के इंजन को जो है ना उसको किसी हद तक बेहतर करना चाहिए। लेकिन जो सबसे इम्पॉर्टेंट बात है वो यही है कि जो हमारे पास पोल्यूशन आ रही है इंडिया से, उस तमाम पोल्यूशन को किसी न किसी तरह हमें कैप्चर करना है और बरी करना है, और इसके लिए एक जॉइंट और एक नेशनल एफर्ट की ज़रूरत है। दैट्स ऑल।
Thank you, Waqas and Adil, for a very interesting paper, starting from Paris Agreement, going to the storage and also indicating the policy requirements. Floor is open for question, please.
Well, if there is no question, there is one comment I want to make. Adil Sahab, the map you have shown that there are some countries showing the very, carbon dioxide उसमें बहुत ज़्यादा produce कर रहे हैं. On the same map, I will suggest you should also highlight Bhutan, because Bhutan was the first carbon negative country years back, and we have to learn many things from them as well.
Yeah, that's true. That's true.
Right? Thank you very much, gentlemen. Thank
Adil,
you.
there is one question from my side. It's Irfan from GHPL. Excellent paper and very good attempt. It's a need of an hour for this country and this nation, no doubt about it. My question is that how can we capture the carbon dioxide from the environment, which you have quoted that it is coming from the India and things like that? What technology and what you suggest and what is happening in the world basically?
Two types of the technologies, they are recently present. One is actually equipment है, उसके अंदर आपकी जो है ना क्विक लाइम पड़ा हुआ है, वो फ़िज़ा से जो है वो आपकी कार्बन डाइऑक्साइड को कैप्चर कर रहा है, उसका सोल्यूशन बना रहा है. और दूसरा सिंपल है कि जहाँ पे आपकी ये जो फर्टिलाइजर्स यूज़ हो रही हैं, ये जहाँ से आपकी एमिशन निकल रही है, उसको डायरेक्टली किसी चिमनी के थ्रू आप किसी स्टोरेज टैंक के अंदर जो है ना वो लेके जा रहे हैं. यही दो मेथड्स हैं. इसमें कुछ चीज़ें मैकेनिकल इंजीनियरिंग से रिलेटेड हैं, कुछ केमिकल इंजीनियरिंग से रिलेटेड हैं. अनफॉर्चुनेटली मेरी नालायकी है, मैं समझ नहीं पाया.
Thank you very much, and I understand there will be more questions, but I will request ladies and gentlemen to catch Waqas Saab and Dr. Nadeer after this session. Thank you very much.
The last paper for this session will be presented by Amar Iqbal Bhatti Saab, who is working in SLB Pakistan as a geophysicist in digital subsurface solution DNI. He has more than 10 years of experience as a geophysicist. Before his current role, he worked for United Energy and OME Pakistan as exploration QI geophysicist. Holds an MSc degree in geophysics and BS degree in geology from Berry University. Please welcome Amar Iqbal Bhatti.
Thank you, Mr. Chairman, for this introduction. So, good afternoon and assalamu alaikum, everyone. So, my name is Amar Iqbal, presenter and one of the authors for this paper. So, the topic of my presentation is unconventional 3D seismic reservoir characterization using multidisciplinary approach, which is a case study from Lower Indus Basin, Pakistan. Okay, so outline the agenda for today's presentation is I will start with the objectives, which are the objective of this studies, followed by introduction to study area. Then we're going to discuss about lithoclassification using petrophysical analysis, followed by rock physics analysis. Then we're going to move to pre-stack seismic inversion and its components like inversion-based lithology classification, petrophysical property prediction, and seismic-based geomechanics, which include stress prediction estimation and pore pressure estimation, followed by concluding it with the summary of this presentation. So, 3-point agenda. We have the objective. Objective for this study was the primary objective was to classify the rock facies based on the shared reservoir quality factors, which are corrosion and porosity. So, the second objective was to identify the distribution of best quality source rock, which are sweet zone for the well placement. And the third objective was to identify the regional stress and its orientation for the development of effective well completion strategies. So these were the three agenda for the three objectives for this study. So introduction to the study area. So the study area lies in the southern part of Pakistan, which is geologically located in the Lower Indus Basin, Pakistan. You know the tectonics, it's a normal faulting regime characterized by high angle vertical faults. So in the basement, so this is the exploration license which is operated by OGDCL Pakistan. So you can see the base map showing the location of wells as well as the seismic data which was provided. Or in the right hand side, you can see the generalized stratigraphic column of the area. So mostly we're going to focus on the shales of early Cretaceous which are from Sambar formations. So the first thing is the lithology classification, so which was accomplished using the petrophysical analysis. So based on the petrophysics, we computed the volumes of different mineralogies. Like for example, we have computed for volume of clay, quartz, and carbonate. In addition to these three mineralogical volumes, we have also computed kerogen, volume of kerogen, as well as porosities. So these 5 factors were collectively used with different cutoffs to define the lithologies within this complete section. And based on this analysis, we can define 7 different classes, which are shown in this legend color coded with respect to each facies. So out of these 7 facies, the 2 main facies of interest are yellow, which are high kerogen siliceous shales, and green, which are low kerogen argillaceous shales. These 2 facies have higher amount of kerogen with respect to background rock, and these 2 facies are present in sambar formations. So once we identify the facies from petrophysical analysis, we can move on to rock physics classification. So the purpose of rock physics analysis is simple to predict and to discriminate the facies within the sambar formation using elastic log. Because the ultimate output from seismic inversion are these 2 properties, which are acoustic impedance and VPVS, which are actually elastic properties. So in the right hand side, you can see the cross plot analysis for the sambar formation, where we have on the x-axis we have acoustic impedance, and on the VPVS, on the y-axis we have VPVS, and these data points are color coded with respect to litho classes. So we can see that we can differentiate these 2 facies based on VPVS analysis. While for the acoustic impedance, they lies on the same range. However, the VPVS can help us to differentiate these 2 facies. So based on this cross plot, we can generate the PDFs. So what is PDF? PDFs are the probability density functions which shows with the probability occurrence of each classes. So we can generate the PDF, and how successfully this PDF has classified these 2 facies, we can infer it from the confusion matrix. So for the green facies, which is low kerogen argillaceous shale, we can successfully classify it by 74%, while for the yellow facies, which is kerogen rich siliceous shale, can be classified successfully by 77%. So overall, it's a very good percentage for classifying these facies. So for the QC purpose, you can see we have this in situ log, which were computed using the petrophysical analysis, and on the right hand side beside it you can see the litholog, which was predicted using this workflow PDF we have used. So overall you can see we have a good match between these 2. Okay, so once we have the rock physics feasibility analysis done, we can move to seismic inversion. So without going in much detail in this inversion workflow, just to give you a generalized idea, we have used deterministic approach for this seismic inversion workflow, and we have used the low frequency model of 6 Hz because, as you know, the seismic is band limited and it's missing the low frequency component, and we have used the wavelets. Final wavelets were extracted from conditioned seismic data because the PSTM gathers, the input seismic data provided was noisy, so we applied some conditioning to improve the signal to noise ratio. Then we have flattened the gathers and stacked them again and regenerated the wavelet for the inversion. So you can see that this is just a comparison between the conditioned data set, which is on the left, and the original seismic data, which is provided in the middle. And on the right hand side, you can see the amplitude spectrum of these 2 seismic data sets. So the noise is clearly removed. We can see the uplift of frequencies, which are probably from the higher side, while preserving the low frequency band as well. So, and overall, there was a much improvement in quality of seismic data and improvement in seismic signal to noise ratio. So this is just a comparison in QC. So this is the seismic to well data analysis before conditioning the seismic data. So we have the seismic on the both sides, and in the middle we have synthetic seismogram, which was generated from the logs. And this is the amplitude spectrum, phase spectrum, and this is the shape of the wavelet, and this is the static. So after conditioning the seismic data, we can clearly see the uplift in vertical resolution of seismic. So the statistics tell us that we have improved, there is a much improvement in signal to noise ratio after conditioning the seismic data. Beside that, we have also improved the predictability and correlation coefficient between seismic and well data. So now we can extract a stable and reliable wavelet from this condition seismic data. So once we made the seismic to well data analysis and extracting the wavelet from each angle stacks, we can use this wavelet to invert our seismic data. So the output from this seismic data are acoustic impedance and VP/VS ratio. So in the right hand side, you can see well and seismic based acoustic impedance and VP/VS seismic impedance, VP/VS ratio. So these are compared with the well VP/VS and acoustic impedance. So the well logs are filtered to the seismic resolution. So overall, you can see there is a very good match. I would say like an excellent match. And on the right hand side, we have the lithocube, which were generated using these two properties on seismic and its comparison with respect to the litho log computed on the well. So focusing on the sample formation, so once we have these two properties, elastic properties, acoustic impedance and VP/VS ratio, we can generate the lithofacious cube, which you can see color coded in yellow and green, and use the computed PDFs on the well scale can be applied to these two volumes to generate the probability volume for these two facies. On the top right hand side, we can see this is the probability volume for low corrosion argillaceous shale, which scale range from 0 to 1, and in the bottom we have probability volume for high corrosion siliceous shale. So out of these two, we are mostly interested in this high corrosion siliceous shale probability. So next is the petrophysical property prediction. As you have seen, we have computed probability volumes from seismic inversion result. In addition to the probability volumes, we can also compute the porosity from seismic inversion results using acoustic impedance to porosity transformation. So you can see these are the maps from one of the layer within the sample formation. On the left, it shows the probability distribution of corrosion-rich rock. On the right, it shows the probability. In the right, it shows the porosity distribution from one of the layer in the seismic. So based on our analysis and understanding, we understand that these two properties are the main factor which are contributing the reservoir quality within the sample formation. So what we can do, we can combine these two properties to highlight the sweet zone within the sample formation. So the red, which you see in the bottom cross section, are the sweet zone which we're generating by combining these two properties and applying certain conditions. So these red zone contain probability of corrosion greater than 65% and porosity which are equal to and greater than 4%. So this red zone contains this information. So we can see that this sweet zone are mostly highlighted and present within the middle part of the sample formation. So up till now, we have seen the rock classification and seismic inversion based classification to drive the reservoir quality. So for the completion strategy, like for example, placing the well, especially horizontal well, we need to have the idea about the magnitude of stress and orientation of the stress directions. So for that, we need to have the understanding of the stress regime of the area. So you can see the depth structure map of sample formations where we have different wells on it. So out of this well, we were having the FMI data available within these 4 wells. So the FMI data interpreted provide us the information about the fractures. You can see the orientation, the Rossborough diagram of these fractures, as well as the breakout and induced fractures. So breakout, induced fracture. So the student at the bottom shows the plot of this breakouts as well as drilling induced fractures which are in blue. So this information indicate, the breakout information indicate that the minimum horizontal stress is along northeast and southwest direction. So this information is very critical if we are going to place the horizontal well, because the horizontal well should be placed along the minimum horizontal stress direction. Okay, so the next is the pore pressure prediction, which is the key component for estimating the minimum and maximum horizontal stress. So for the pore pressure prediction, we analyzed the well, and based on analysis, it showed that the sample formation is over pressured. So if you look at the velocity measurement with depth, we have used Eaton method for predicting pore pressure from logs. So if you look at the velocity trend with the depth, we can clearly see the velocity is increasing with depth until we reach the top of the chamber, where the velocity suddenly decreases, which shows the onset of pore pressure, as well as it shows the sample formation is overpressure, which is also true because during drilling, we have to increase the mud weight within this section to balance the drilling parameters. So we use this velocity-based equation to predict the pore pressure on the well. Similarly, this technique method equations were used to predict velocity, to predict pore pressure on the seismic data using seismic inversion results. So in the right, you can see the comparison between well and seismic-based pore pressure prediction for these two wells. Okay, so once we have the pore pressure and inversion result, we can estimate minimum and maximum horizontal stresses. So by using these two properties, we estimated minimum and maximum horizontal stress magnitude and calibrated it with the well-based measurement. So on the left-hand side, we have minimum horizontal stress, and on the right, we have the maximum horizontal stress comparison between well and seismic, and this is their scale, which range from 0 to 2000. So the purpose of calculating the magnitude of these stresses is that because it gives us the idea about the fluid pressure required to induce the fractures in a source rock. So this can help us to optimize and program our drilling campaign for this in the source rock category. So the summary, we have seen that the marine current area which control the reservoir quality is the presence of porosity and corrosion, and these properties were predicted by integrating petrophysics, rock physics, and seismic inversion result to bring up with the sweet zone volume. And the next thing is the prediction of completion quality. We have predicted the seismic pore pressure and integrated with the stress knowledge, regional and local knowledge of the area to estimate the magnitude of the stress volumes, which are minimum and maximum horizontal stress to support our drilling and fracking strategy. So the value of this workflow is that it shows the integration of all different disciplines for the prediction of reservoir quality and completion quality. So based on the result of this study, a few frac tests were conducted in a vertical well, and the results were found to be successful. And that's it from my side. Thank you, everyone. So I would like to acknowledge and thanks OGDCL and Schlumberger management for permission to present this paper, and I would like to thanks to the colleagues from OGDC and SLB for their support during this study.
Thank you, Emmerich Balbatti, for your nice presentation, taking through the seismic inversion and looking at the rock mechanics as well. Now floor is open for question and answer, please.
Yeah. An excellent paper, very nice. I mean, I just got one question, when you compare the estimation of pore pressure with the actual data, what was the margin of error, how close you were with the actual measurements? Or your confidence level,
I think we were pretty much close. I would say like 5 to 10% of error, it was there. Not more than that. The answer presented paper before the tea break, it was just a part of that as well. So I don't know if someone asked that question from answer. So up till now, what I'm aware, it was around 5 to 10%, not more than 10. We were pretty much confident with this pore pressure prediction.
Hanif Khan from Diwan Petroleum. Very nice presentation. My question is there any core data available in the wells, what you showed? Or if available, then you did not discuss about any correlation, especially the TOC, which is calculated by, from the logs and then raw,
we computed volume of corrosion on the log basis. We do have core and ditch cutting data available with us. We have computed the TOC on this cores and ditch cutting, and we calibrated our logs with the core.
Okay, thank you.
Each log was calibrated with the core data.
Okay, the next question is, it's a small thing, it's a comment. When you are saying the corrosion, so basically you are talking about the TOC, right? Is it?
No, it's corrosion is after the TOC identification with respect to certain equation. I'm not a petrophysics, I have no idea about the details. Okay, so it was used in the equation, the TOC calculator was used in the equation to come up with this volume of corrosion.
Yeah, it is just a comment that when you talking about the sweet spot, especially in the shale play, So you are talking about two things. One is the TOC. The next is the thermal maturity, which is the VR value.
Yes.
So that is show your sweet spot. Thank you very much.
Okay. Okay, this is a nice suggestion. Thank you.
Ji, any other question, please?
Thank you for the nice paper, and that concludes this presentation. So this session is coming to an end. Samad will take over.
Thank you, sir. So we'll move on to the shield distribution ceremony for this session. I would like both the chairs to please stand up so that I can send you the nominees. First of all, I would like to invite Mr. Asad Taimur along with his group, which includes Mr. Umar Manzoor, Mr. Muyassar Hussain, Ms. Noorul Huda Chaudhary, and Mr. Mohammad Khizar. Please have a round of applause for them. Mr. Asad Taimur, if you please come on the stage. Asad. Claps, please. Mr. Umar Manzoor. Mr. Muyassar Hussain. Okay, Mr. Mr. Mohammad Khizar. And Ms. Noorul Huda Chaudhary. I would like you all to please appreciate these people because this is the only thing which motivates them to write more and present more. Now from Group 2, I would request Mr. Waqas Habib to come along with his team, which includes Mr. Adil Nazir, Iftikhar Ali, and Shabir Ahmed. Okay, they're coming. Mr. Waqas Habib, please. Mr. Shabir Ahmed. Dr. Adil Nazir. Is that right? बस उनको क्या मैं कर I think they receive a round of applause for such a nice presentation based on carbon sequestration, which focus on the future challenges which we are facing, which we will be facing in near future. From Group 3, I would like to invite Mr. Amar Bhatti, Mr. Faraz Siddiqui, Mr. Naveed Ahmed, Mr. Shahid Javed, and Mr. Mohammad Saqib. Can you please come on the stage and receive your shields, please? So Mr. Amar Bhatti is coming. Naveed Saab will be following suit. And Mr. Saqib is also on the stage. Please a round of applause for them. Mr. Muyassar Hussain, if you can please come on the stage. Your shield was missed. Please, you can line up over here. Please, a round of applause here. All the authors, all the presenters, they deserve this applause because this is what keeps them going on. And they can be, next time, they can be from amongst us also. So every one of us would like to see this applause, which urges us to do more and do more research and present more valuable things to you. Because since this is a technical conference, so this is the basically essence of this conference. Now I would like to invite Mr. Shamim Chughtai and Mr. Azim Subhani to please come on the stage to present a shield of honor to our esteemed chairpersons. A round of applause for both the veterans. First of all, I would like Mr. Shamim Chughtai to present the shield to Mr. Farooq Saghir. And I would like Mr. Asim Subhani to present the next shield to Mr. Shifat Alam. Sir. So basically this concludes all the GNG sessions of a very exciting annual technical conference. I would like to thank everyone, the presenters, the authors, the chairpersons, and most of all the organizers of this very brilliant annual technical conference. And I would like to thank especially the SP Pakistan chapter and the PAPG who worked day and night apart from their official schedule to make it a success. So a round of applause to especially the organizers of this organizing committee. And on this note, I conclude the GNG sessions of the 29th Annual Technical Conference and Oil Show. Thank you. Have a pleasant conference.